Hey guys, I'm Clint Cannon here with ATS, and today I'm going to spend a little bit of time going through the really intricate details of the 6-8 RFE. In general, I'm going to start with the torque converter just because there's so many changes that have happened to this transmission over the last 15 years. You know, when this came out in 2007 and a half with the 6.7, you know, really nobody had any idea what we were in store for as far as the 68 goes. And you know, we all know that the 68 RFE is a grown-up 545, which is a gas tranny, and that's essentially what we're dealing with. So, you know, we had a lot of work to do. I mean, a ton of work to do to make the 68 work. But I tell you, after all these years of building them and taking a lot of scars in the process, figuring out what makes them work, we've got a fantastic recipe that we're pretty much putting in all of them now. So I'm going to kind of start with the torque converter. You know, the torque converter is a, you know, welded together biscuit, so to say, that has this magic going on inside of it. Well, there's a couple basic functions of a torque converter. The torque converter is designed to disengage when you come to a stop. When you accelerate, the fluid increases and it pushes fluid from one fan to the other, turns the input shaft, and it moves down the road. When you get up to speed, then the fluid is basically inverted through the converter and it goes one-to-one, and it maintains a one-to-one lockup, a mechanical one-to-one lockup. And that mechanical one-to-one lockup is essentially what gives you that 100% efficiency. Well, there's a lot to learn and a lot to know about a torque converter. I'm going to kind of break it down, make it pretty easy. So I'm going to start with the first torque converter, or the original torque converter. This is basically your stock 6-8 RFE torque converter that's been essentially built since 2007 and a half. Still builds the same thing. Nothing's really changed in it. These torque converters, you know, were designed to handle basically a max pressure of about 160 psi working pressure. And that essentially is one of the issues that everybody falls into when you put a torque converter in front of a 6-8 RFE, because the entire industry, us including everybody, we've learned that we need to increase line pressure to somewhere in the 250 to 270 psi range. And when you increase that pressure to squeeze the clutches together, that means that adverse things start to happen, which I'll really get into that a little bit later here in a few minutes when I start talking about the transmission, but I'm going to kind of concentrate on the torque converter for a moment. So some of the problems with the factory torque converter is you have basically this stamped steel cover. You know, it works fine for lower line pressure applications, stock tranny. It doesn't work well for a modified transmission just because it deflects, it, you know, doesn't have the strength. It's basically manufactured so it can be built very inexpensively and in mass production. Well, it basically has a single disc in it that's kind of sandwiched by like an encapsulated clutch, which again is relatively okay until you start putting horsepower to it, or a ton of weight, or increased pressure. So that's when this whole assembly basically becomes kind of obsolete or out of its work zone, because it's just not designed for the increased power or torque or pressure. So a couple of the other things you're going to note is, here's your input shaft to the transmission. This input shaft basically goes into the torque converter, and you see how it goes into this metal clad sill? Well, the metal clad sill again is designed for somewhere around 150 psi line pressure. It's really not designed for really big pressure because it's a metal sill that has rubber vulcanized to it, and that vulcanized rubber essentially is limited on how much pressure it will hold. So we're turning pressure up, that becomes a big failure point. I'm going to point out a couple of these things because I want to show you what happens to a typical competitor's torque converter, and basically what's out there on the market. So when we get into some of the other attributes of it, the dampener. Dampener is very, very important. A dampener is designed for basically one thing. When the torque converter clutch engages, that means when the clutches smash together and they're engaged between the cover and the piston, that they go one-to-one, and you have to have a cushion between the engine and the input shaft. This is the input shaft of your tranny. This is your engine. You got the engine spinning, and when it goes one-to-one, when the converter clutch engages, all of that torque is going through this input shaft. That means that you're spinning the rear wheels by hanking on this, by turning this input shaft, and that's where all the power into the transmission goes, is through that torque converter clutch, through the dampener. The reason the dampener is so incredibly important, especially on a Cummins has 6 cylinders. It's not a V8, it's 6 cylinders. That means the pistons are bigger, the stroke is longer, and they make a tremendous amount of torque. The Cummins 6.7, the Cummins 5.9, all of the Cummins inline 6-cylinder engines make just a ton of torque. And that kind of torque, when that when the piston is exploded and you fire the piston going down, it turns the shaft and it creates these massive torque rises throughout the rotating cycle. And those engine torsionals is essentially what breaks things. And you'll find a lot of manufacturers, they say they will not ever put in a stock input shaft. There's a reason for that, because the stock input shafts, when you take all that engine torsional and put it right to the input shaft, it doesn't live. It breaks the input shaft, it breaks the intermediate overdrive shaft, it breaks the planets, it literally destroys the transmission because the engine torsionals are being transferred right to the front of the tranny. So we start moving into some competing designs. One, you'll find this is a very prevalent, the most common torque converter out there that is pretty much manufactured by just about everybody in the industry, is you have your basic piston. Well, you see what happens here. There's no dampener. The factory converter has a dampener. These guys chose not to build the dampener, and I'll explain why. And then they go to a cover, this one-piece cover. One of the other problems with it is the way the clutches are engaged. Remember, these engine torsionals are banging on this cover, okay? When this thing is spinning, all those engine torsionals are pushing on these tabs, and if you have smaller tabs, essentially not square, which I'll kind of explain why we went to a square tab, then the tabs themselves are really compromised because you can only get so tight. So they rattle around, right? Well, over time, all those engine torsionals are beating on it, and over time it just wears out the steel, and the steel is kind of floating around the cover, and it eventually fails. That's a lesson I learned a long time ago, somewhere around 2003, 2004, which is one of the reasons we have a few patents on our torque converter. The square tab versus the round tab is one of those. So I'll go into a little bit more detail. The other thing you'll find is because of the amount of force that's going from the impeller, which is, this is your drive fin, essentially this is what's hooked to the engine. Fluid is being picked up in the impeller and it's being spun around and then forces into the turbine. This turbine catches it and that fluid pushes it around and spins your input shaft. Well, all of that fluid energy is not only rotating the turbine, but it's also pushing the turbine into the cover. So your cover ends up being pretty abused, and all that thrust has to go between the turbine section that I'm showing you here, and then it pushes on this thrust washer and it pushes against the cover. Well, that's another issue. The factory put a bearing in it, right? For good reason. It's not a very big bearing, but they don't use thrust washers anymore because the amount of abuse this thing takes, again, especially behind the Cummins. So the aftermarket companies mostly went with, you'll probably recognize that cover, with basically a thrust washer. So you have a thrust washer and then you have your piston that has round tabs without a dampener, and then you have your turbine that fits into it. Now you have a one-to-one connection when that thing is locked up. Well, that becomes a problem, especially when you're turning power up, you're putting a lot of demand to it, or you're just cruising at lighter throttle and the engine torsion is going boom, 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 boom. And you remember the Cummins makes tremendous torque, you know, at 12, 13, 15, max torque at 1700. Well, you're cruising down the interstate or the highway or whatever it is, and you're running, say, 40, 50 miles per hour, and your RPMs are at like 12 or 1300 RPM, and you're locked up. That means every engine torsion is going bam, 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 bam. And it's beating the hell out of your cover, your tabs, and your input shaft because you don't have the dampener there. So this is really, move all that aside and I'm going to show you what we do. So addressing all of this, first of all, we build a square tab construction, right? So these square tabs, this is our cover, basically. Now back it up just a little bit more. This is how our cover starts. Our cover basically starts as one big piece of material, and then we mill the slots in it. That's essentially how we get our slots. That allows the frictions to fit into it. You see how nice that is? So you have your multiple frictions that are fitting into it. And then the piston fits into it. Well, this is half the battle. So in order to make the square tabs, we have to make a two-piece construction cover. And our two-piece cover is essentially built by starting with that, then our ring, then we fit it together and weld it, and then we go through the final machining process, and we end up with a cover that you see here. So we increase the amount of bolts, which is really helpful, because when you put it on with our billet flex plate, it basically doubles the amount of load on the cover and the flex plate, so the flex plate doesn't break anymore. By the way, broken flex plates are also highly attributed to broken input shafts, which is attributed to no dampener in the torque converter. So again, anytime you dampen, when these things are spinning, you're going to take that stress out of the hard parts. So it really comes down to a dampener is very important. You notice the bearing that we put in here. This bearing is what holds the turbine. That takes all the thrust load. So instead of having like just a thrust washer, that bearing holds the turbine fits into it, and now all your load is distributed through that bearing. So a really well built, very well designed piece. So that kind of covers the cover, so to say, in our square tabs. The square tabs is, what allows really us to offer a 5-year warranty on these things, just because the engine torsionals don't beat it up. It doesn't kill it. So now we'll get into some of the really interesting stuff. I showed you this metal clad seal, right, before, that's so problematic. They come in ripped all the time on the factory converters. We see it a lot on the aftermarket converters, but we don't see it anymore because we designed a nice mechanical seal. So this is a small part, but as I showed you, that little factory rubber where it goes in and leaks and has an issue, what we've done on ours is we build, I'll just grab that stator and cut myself. We build a nice mechanical seal. So this mechanical seal is basically an encapsulated O-ring. And that encapsulated O-ring, you see when the input shaft goes inside of it, we put a double O-ring on it, again for security. If an installer happens to install our torque converter and they don't lube the front of it and it peels the O-ring, then you have a secondary O-ring as a backup. Just another little thing we've learned that's it's been just amazing for completely 100% eliminating failures. Then we put an O-ring on the outside. Well, the O-ring on the outside goes into this turbine and it fits right in. So now what you have is you have a nice seal, right? So now you have double O-rings. This is basically just an idea I had from high pressure cylinders. Working on, I'm kind of a junkie when it comes to mechanical things, and that's something that I saw in a really high pressure cylinder at some point, and I thought, we need to incorporate that into our torque converter design. Well, the converter you're looking at, we've gone through so many design changes. I think we've gone through 5 or 6 just turbine spline changes. This was one of the small ones. So it goes in there, puts a spiral locks in it. The spiral locks is basically something I got from a motorcycle piston. Anytime, you hold a wrist pin in, the really high RPM engines use a nice little spiral locks ring. That's what we put into the turbine. That's what holds it together. So we've just come 100% eliminated a failure point of an installer installing the input shaft or the torque converter into a tranny, which is very common with aftermarket torque converters and a factory converter. That part got eliminated. All of the turbines were always, of course, furnace braze. That means everything's welded, no deflection. That's pretty standard issue. I mean, everybody's knows about furnace brazing, but it's something that really stiffens up the whole assembly. So now we get back to the piston. Well, the piston, I mentioned earlier on these competing designs where they don't put a dampener in them. And you might be asking yourself, why don't they put a dampener in it? Well, let me tell you exactly why they don't put a dampener in it. Because of the construction of the factory core. We all know that the entire industry runs on cores. That means the core, the unit that comes out of your vehicle, it comes back to the shop opens it up, and then they start with that, and they typically use the turbine section, right? And then they'll usually use the dampener. Then you put a piston on it, which gives you your multiple clutch, then to upgrade your impeller and your stator and everything else. The problem with the 68 RFE is, again, the Chrysler converter does not lend itself to being able to utilize the factory dampener. So that puts you at a really bad spot. And the reason for that is because the way the springs are positioned, you can't put you can't attach like a kind of conventional piston to this just because of the design of it. So pretty much what did the aftermarket do? Say, well, we're just going to cut the turbine out and then we'll build a billet piston and a solid billet piston and make our splines. So now you can use that factory piece, drop the splines in there, and then put a billet piston on it, and voila, you can build the unit. This is where things really got separated, because all of our 68 RFEs, not only did we have to go and build the cover and the piston and everything else, but we now had to build a dampener that would allow us to fit to a turbine that would fit all in the same package. So if you look at your stack height, and I don't mean to get too technical here, but I kind of have to explain this, right? So your stack height, you don't have any more room from factory to aftermarket, right? So this is the other guy's aftermarket. This is R. So you see the stack height here. In order for us to get that spring dampener included in the assembly and make it all work, we had to go to some pretty extreme measures of getting our hands on, getting the parts to put a dampener into it, and then engineer everything around the dampener so it all fits in the same space. So that's ultimately why the other companies don't have dampeners in their converters, because it's cost. I mean, it gets really expensive. Now, one of the unique things about ATS, one of the things I'm really proud of, is everything that you see here, everything we build is built not only here in the States, not only in Colorado, it's built right here in Arvada. So all of these parts come in to our machine shop upstairs, and they're laser cut, and they're machined, and they're broached, and we put all these pieces in them. And everything here, we build. That gives us a lot of advantage over pretty much everybody else, because we have the initial designs, we build them as we go. We crank these things out, 50, 100 at a time. If we have a small design change like this guy, guess what? We identify it, it goes into production, and within a couple weeks, we have the very latest pieces going out the door. So when you really sum it all up, kind of bring it together, make sure that when you're shopping for a torque converter, make sure that you ask and you verify that the torque converter that's going into your vehicle has a dampener in it, like a true spring dampener, like that, something that will that will absorb those engine torsionals as the engine is beating the transmission up. Now, like I said earlier, that goes far beyond the torque converter, because all those torsionals are going right into your transmission. So you're not going to get the longevity out of the transmission. You're going to be forced to, if you don't have a dampener, you're going to be forced to add a billet flex plate. You're going to be forced to add a billet input shaft. You're going to be forced to add billet hubs, or they break. That's the reason they break. Our stage ones, for years and years and years, we didn't put billet input shaft in them. We didn't do the billet intermediate shafts. They didn't break. Started hearing about these other companies that they were constantly breaking intermediate shafts or overdrive drum shafts. And come to find, I assumed that everybody was putting a dampener in these things, and so these converters started coming in, and we're cutting them open, and we realized, wow, I think we might be the only ones that are actually putting a dampener in our torque converters. So again, just want you to be educated. Some of the other things, the stator is what redirects fluid from the impeller to the turbine. That's where your drivability and torque multiplication, that's the kind of stuff comes. This is basically stock. This is generally what we see in competitors' converters when they're coming in. Sometimes they put a bearing on them. Fact is, they're kind of cast components. We have a lot of different stator designs, but this is what I just cut myself while I'm carrying this rag. But the stator, essentially, this is another full billet piece. So we do hardened splines in them. The assembly itself, rhizome bearings. So the entire converter, the stator, the turbine, the cover, everything is riding on bearings. And that means that you can stack them up really tight. When you stack the converters up really tight, when it goes from the cover to the impeller to the turbine to the stator, you know, all those pieces, you can stack them up tight. That means your fluid transfer from your impeller to your turbine is going to be maximized. That means when you're accelerating from a stop and that fluid is coming off the impeller and it's going backwards engine rotation, that it hits the stator, it efficiently redirects and goes back into engine rotation, and that's your torque multiplication. That's why when you upgrade the converter and you give a little bit of throttle, how it accelerates really nicely and pulls away from a stop, that's all about the stator. So anytime you get an ATS converter, generally have a couple of different stall options. This is what it is. That's your billet stator. So, you know, always for the best billet cover, square tab construction. Again, that's one of the patentable items. Two-piece cover, mechanical seal on the cover, billet piston, heavy-duty clutch pack, billet stator, and then the whole assembly is basically zipped together and it's welded up, and that's your torque converter. So that's kind of a basic overrun of what you get with a ATS triple lock or a 5-star converter. So now I'm going to move over into the transmission and kind of show what happens after it leaves the torque converter.